we will begin by drawing our beam. We will click on Create Part. You can give a name to our part here. We will perform the analysis on a deformable part drawn from an extrusion. And we will start by drawing our rectangle. We will specify its dimensions, which are 25 mm by 20 mm. Then, we exit the function and click on Done. Now, we can choose the depth of our beam, which is 200 mm, and click OK. That's how we've drawn our beam using an extrusion. Next, we will go to the Properties module and create our material. We will use the steel material and perform an elastic analysis. Therefore, we will input a Young's modulus of 210,000 megapascals and a Poisson's ratio of 0.3 for the steel. Next, we will create a steel section. It's a solid section, and we will assign the steel material to this section. We will finish by assigning this section to our beam. We click on the Assign Section function. Then, we select the beam and choose the steel section we just created. The beam changes color to indicate that we have added a section to it. Now, we are going to bring our beam into the assembly module. Next, we will move to the Step module and define our analysis step. We will proceed with a general static analysis. In the Load module, we will add forces and boundary conditions. We will start by defining the boundary conditions, which will be added in the initial step. We select the regions, then click Done. For this example, we will encastrate the surface. The forces will be defined in the step we just created. We will choose to apply a pressure to the surface. We start by selecting our surface and applying a pressure of 0.5 megapascals. In the Meshing module, we start by clicking on Part. We begin by creating the initial mesh. Then, we can change the element size. We can set it to 10 mm instead of 20 mm, and then remesh the part. The Assign Element Type function allows us to choose between using linear or quadratic elements, and don't forget to uncheck the Reduced Integration option. We can also display the number of nodes in our model using the Query function. Here, we have 849 nodes. In the job module, we will run our analysis. To do this, we'll start by creating a job. Then, we click on the Job Manager and select Submit to initiate the analysis. You can track the progress of the analysis by clicking on Monitor. Once the analysis is completed, we click on Results. We start by displaying the deformed shape by clicking on this function. Abaqus displays here the equivalent stresses according to von Mises. We can also display the normal bending stresses. In our case, we will choose S33. We can also display the displacement in the y direction. In our case, we have a maximum displacement of 0.7 mm.